This conference will now be recorded.
Okay, in this section, we are going to talk about cookies and other headers in the request. So cookies are nothing but a name and value pair. So we are going to discuss what is the main purpose of cookies, what all cookies are being inserted by ASM as part of response, what are the various attributes of it, how security processing on HTTP headers work, and then we'll configure a application security policy to protect against both cookie and HTTP header tampering. So let's first understand ASM cookies. ASM uses two primary types of cookies to prevent various forms of cookie tampering or to enforce user sessions, login pages, and to distinguish between a human and non-human clients. These two cookies are TS cookie and frame cookie. TS cookie validates domain cookies which are already set up by the application. It detects session expiration. It helps us protect against brute force attack. Using TS, we enforce login page. We can protect against web scraping. And frame cookies help us to enforce the URLs. So URL navigation within the application is being protected using this enforced frame cookies. So dynamic parameters we protect using these frame cookies. So most of the applications, set cookies for user tracking, shopping cart functionality, or maybe other reasons which are related to users experience. So when you're trying to capture HTTP traffic and see in the HTTP packet, we'll have a specific header called as set dash cookie. Let's call this as trial equal to yes. And then the path would be defined. The domain would be defined. Say domain is .abc.com. And then you have secure and HTTP only attributes. So if this set dash cookie header is present, ASM will perform a hash on this cookie and insert the hash value into its own TS cookie, which is named as TS underscore XXXX. Thus, ASM generates its own cookie in the response, which is specific to that domain .abc.com. Maybe in addition to any possible different domain or path combinations. If either the cookie which is set by the application or the cookie which is inserted into the response by ASM is tampered, then a violation will get triggered. So ASM validates its own cookies by signing each one with MD5 digest and then enforcing matches between cookies using a proprietary message key. So this TS cookie also helps us in detecting session expiration. So now let's try to understand the structure of this TS cookie. So the main ASM-TS cookie structure is something like this, and these are a hexadecimal representation of when you see the policy name, right? Like this, the TS cookie like this six characters are nothing but the hexadecimal representation of your security policy name. And this is a structure of the TS cookie on how it looks. Signature is nothing but the MD5 digest of the remainder of the cookie. Message key is a randomized byte sequence which connects the TS cookie with any other ASM cookies. And timestamp indicates when the cookie was created. This can be used to verify that the cookies are not too old. And cookie name and value pair is set as per the response which is coming on from the application. So now, with respect to these cookies, ASM assigns two attributes. First is allowed, and the second is enforced. The allowed attribute is used for cookies that ASM knows or recognizes as cookies which can be modified externally. These might be, any persistent cookies which have been set by the application, any single sign-on cookies, or any other modified cookies. So when ASM receives a cookie which was set as allow, ASM will ignore it and a violation will not get triggered. Allowed cookies can again be of two types, like explicit or wildcard. Explicit lets you input the cookie name exactly as it appears in the request, and wildcard is just the asterisk to match and learn the pattern of expected cookie. And then you have enforced cookies. The enforced attribute is used for cookies that are signed by ASM, and it should these are signed by ASM and should not be modified on the client side. So consider a session cookie set by an application. This is usually the type of cookie that should be enforced. So if a cookie with the attribute enforced cookie is modified on the client side, then ASM will trigger a violation as modified domain cookie. And even if a cookie appears in an enforced cookies list, it can still be in staging, and a violation will not trigger in blocking stage. So for this to be blocked, again, this enforced cookie has to be removed from staging and the policy has to be in blocking mode. Now, this was all about cookies. Now, security processing on HTTP headers. So ASM,
Vinit,
yeah,
sorry to interrupt you. Related to the allowed cookie, okay.
mm,
So it will be basically those cookie can be modified on the client side as well, is it?
yes. So these are something which the application knows that this can be modified as and when the application flow is happening.
Mm-hmm.
different instances. So that we explicitly allow in the security policy, telling that okay, even if there is a modification, it's all fine, it's okay.
And is it that something a normal user like will have to do something, or it will get automatically modified on the client side?
No, it is something which client has to explicitly do. If you want to modify it, you have to
Okay.
explicitly do it, or maybe you can
Okay.
run some scripts at your end to
Mhm.
perform the modification.
Okay, got it. Thanks.
Then with respect to HTTP headers, we have different ASM can apply different kind of attack signatures, and we can ASM also performs something called as normalization. Normalization is nothing but the process of buffering the contents of your request headers to change them into a standard format that can be more easily checked for any discrepancies, and or to ensure that it is RFC compliant, or we can apply attack signatures and see that no attack signatures are matching. So normalizing especially deals with special characters like percent encoding or non-ASCII text, URL paths, parameters, base 64 encoding content, HTML codes. So if let's say we consider this URL slash user accounts slash index.php. So in this specific URL, a space exists in the path for user accounts. Between user and accounts, a space exists. This is a valid structure on the web server. Therefore, it is required to be part of the URI. When web servers receive requests that are URL encoded, which means that any special characters in the string be translated into a form that the web server accepts. So for this specific request, the encoded format or the encoded request for the same URL would look something like abc.com user percentage 20 accounts slash index.php. So any amount of malicious or arbitrary character data can be encoded or altered in other ways before it is actually sent to an application. So normalizing basically helps us to decode this request and then apply various attack signatures, see whether it is matching any of the attacks. So some headers such as referrer header or any custom header or the cookie headers are basically the candidates for normalization because they are the common attack vectors. So in the HTTP headers list, if you go into the security policy, you'll find different headers defined like wildcard, say authorization header, cookie header, referrer header. So by default, ASM applies attack signatures processing to it. So all these headers normalization will be applied, and once the actual request is decoded, then ASM applies attack signatures to those headers to ensure that it is not matching any attack pattern. So now let's do some lab with respect to normalization and cookie tampering to have a better understanding about this. Let me also open Fiddler. So in this, first let me go ahead and create application security policy. Let's choose the language, Unicode, choose the server technologies. And then just create the policy. So now my policy is created. Let me go to my virtual server and assign this security policy. And also ensure that I am logging all the requests. Click update. Now I'll go to my security policy and change the learning mode because I've created a automatic learning mode policy. So I'll go to learning and blocking settings. And the learning mode, I'll change it to manual. Click save and then apply the policy. So before we do anything, let us just go to this cookies list in our security policy. I'll be going to application security, headers, and then the cookies list. So in here, if I see the allowed cookies, at present, I'll only see the wildcard. The application that we are using uses another cookie, which is named as, let's say, session. So now let me go ahead and let's say I will open another tab in a private window. In here, I will access the website. Now I have generated some request. Let me go back to my F5 and go to the traffic learning page. So in here, I see a suggestion for enforcing a cookie. If I click on this, it will say that the matched cookies session. Action is add or update to cookie. Set the enforcement type to enforced. So let's accept this suggestion and keep it in staging. So what I have done is I have accepted the suggestion and then I'll apply the policy. Now, if I go to my application security settings again, the headers cookies list, I will see that in the enforced cookies, I have a cookie session, which is currently in staging. So at this stage in policy building, if we tamper with this cookie, what should happen? So let's check it out. We start Fiddler and let's just do it this way. We'll go to rules, automatic breakpoints, before requests, then again go back to the auction website and click on this. No, 1 second. Did not work. It looks like Fiddler is not working. Let me restart Fiddler and see. No. Let's try it with a different browser. Okay. This is triggering auction. I've generated this request. In here, I come to the inspector section, and then if you see the request headers, a second. Let me break this up again. This seems strange, man. 1 second. Let's try it in a different explorer.
Vinit, is the cookie that we are seeing is in some different format that we are expecting to?
It should be a session cookie, which we have seen, right? In the F5,
Yes,
we got a
in the F5.
suggestion also, and we accepted this suggestion. So the same cookie should
Right.
be seen in my request. So in the browser, for some reason, it is not showing. That is what I'm trying to figure out.
Okay.
Yeah, there it is, the session cookie. So in here, what I'll try to do is I'll modify this header, and the session cookie, which I see here, I'll modify only the session cookie. Let's say this has a specific value. I'll delete some part of it. 1 second. I'll delete only this part. Okay, and then click on save. So I have modified the content of my session cookie, and after this, I'll format complete the request. So I'll click on run to completion, and after this, again, I will disable the breakpoint. So now if I go to ASM and then I go to the traffic learning screen, I will see a specific um, suggestion saying that it is a modified domain cookie. So if I just click on this, I'll see that it is related to the session cookie, and the suggestion which I am getting is set the enforcement type to allowed. So also, if you see in here, if you select the HTTP request, you will be able to see that okay, this violation has matched, and if you see the request, the cookie will be highlighted. Cookie session whose value is currently this. So now what we do is let's enforce this session cookie. So in our traffic learning page, if I go to enforcement readiness summary, if I come down in here in the cookie section, I will get one cookie as not enforced and it is having suggestions. So I'll just click on this digit. It will direct me to the same page. So in here, what I do is I select this specific cookie session and click on enforce. Click OK and then apply the policy. Now let me again reinitiate this tools before request. In here, I edit the header, edit the session cookie, save, and then click on run to completion. So the result is the requested URL has been blocked. So let me again disable this and go to my F5. And after going to my F5, we can see the event logs. We can see that this specific request has been blocked because it is matching the modified domain cookie. Let me clear all these requests. And then let's start with the section of securing HTTP headers. So now we are going to examine the HTTP request for various HTTP header properties. So let's first go in application security, headers, HTTP headers. In here, we will see the different headers which are actually um, attack vectors. So if I click on, let's say, the referrer header, we'll see that normalization settings, evasion detection violations, all these are enabled with respect to my referrer header, and attack signatures also. There is no signature overrides for this specific headers. So attack signatures will still be applicable. So we need to ensure that this check attack signatures is enabled. So with respect to this HTTP header, all these settings has to be enabled. Now let me cancel this to come back to the original screen. And from here, let's again go back to my website. In here, okay, before this, let me enable the breakpoint point again in Fiddler. And from here, I will refresh the page. And do I see anywhere referrer? Okay, in here there is no referrer. Now let me go back to a different page. Let's go to index.php. So in here, let's go to register now or click on help icon. So when we click on these icons, if I just select this specific request, I'll see that there is a referrer header from where the request is actually coming. It is coming from the index.php page. So if I edit this referrer header, edit the header and modify the value, paste, let's say, a tag signature, and then click on save and click on run to completion. So if I see my page got loaded, let me again go back to my F5, and in here I will see on the traffic learning page, policy building, traffic learning, I'll see that a suggestion is there present for attack signature detected. So if I click on this, I'll get the details of the attack signature. So referrer header was modified, which is actually matching a attack signature, bin execution attempt. So now if you want to see why this did not get blocked, that's because signature staging is enabled. So you have to remove staging for this specific attack signature so that this request can get blocked. And alternatively, this is one specific suggestion. So if I click on accept here, what would happen is, do make sure that whenever you click accept on a specific suggestion, you check the action before it, because what here F5 is suggesting is to add that slash bin execution attempt, which will result in disabling on this header. So this attack signature will get disabled on that specific request. So make sure always before accepting the suggestion, you see what is the action that is being suggested. So if you want this to be blocked, remove the signature from staging. So with this, we complete the section of cookies and other headers protection. For now, we'll wind up